We're getting close to the end of the series, 46, integral x over x squared plus 1 times x plus 1 dx. So the professor was probably even nice in this problem because the bottom's already in factored form. So maybe we can do a partial fraction decomposition. It's a rational function, is it not? So there's a linear factor of x plus 1, so it's just a on top. X squared plus 1, that's a quadratic factor, so it has to be a linear factor on top, so bx plus c. Okay? We go through the motions. We multiply both sides by the denominator, and then you get this line over here. We want to match coefficients. It's usually easier when there's quadratic factors, so I expanded everything out and grouped like terms. So we know that a plus b has to be 0 because there's no x squared term on the left-hand side. B plus c has to equal to 1, and a plus c has to equal to 0. Okay? So if we write down the equation, that's right here. And we can make our life a little simpler because b has to be equal to negative a and c has to equal to negative a as well. Okay? So if we substitute minus a and minus a into here, that's minus 2a equals 1. So a is negative half. And therefore, b and c are both half. Okay? So we found the coefficients. We can rewrite our integrand like this now. Integral like this. Okay, the first term is just log. The second term, I broke up into two integrals. This is a substitution. This is just arctangent. I think this is very similar to a different problem we did. So after the substitution, you should get 1/4 ln of x squared plus 1 in absolute values. And this is arctan, as I said. So this is my final answer over here. Okay? This one is pretty straightforward in my opinion. So in typical levels, so you should know how to do this, in my opinion. And again, the big clue was it's already in factored form. So partial fraction decomposition was probably a good method to try.